Hello everyone, welcome to our pre-calculus lesson pre-recording video. This is our second lesson for level 200. This is about introduction to polynomial functions. So let's look at the agenda. Definition of polynomial function, then power function and transformation, real zeros and their multiplicity, turning points and end behavior. So actually we have a bunch of new concepts here that we'll talk about. And for this also, as you know, you will need some uh, basic concepts about previously known function. Kind of like, let's say, what is the graph of y equal to x square? What is the graph of y equals x cubed? This kind of graphs should automatically come to your mind. Then all these concepts will be faster to understand. Let's look, then you will get what you mean. So first of all, polynomial function, what does it mean? So a function, when a function have many terms, poly means many, nomial means term, polynomial. Uh, when a function has many terms, then it is polynomial function. We'll give you the example. So these are the examples of polynomial functions. It can be like even a lot of terms here. Here how many terms? 1, 2, 2 terms, 3 terms, 4 terms, 5 terms. 1, 2, 3, 4, 5. Even one term also sometimes it can be called polynomial because they are the within that boundary, within that umbrella. That is the reason. And then degree of a polynomial function is the degree of the highest power of the variable there. So if you look at this, suppose 3 number, this is actually degree is 3 already. So you see 2x cubed, 5x square, 9x plus 15. So what is the degree here? This is 2, this is the 3, this is 1. So highest is 3. That's why we will say that degree of this function is 3. So the degree, you will see that there are lots of other numbers there, but we will consider the highest one is the degree of that whole polynomial function. This is the degree of the polynomial function. So polynomial function means a function where we have many terms, and the degree of the polynomial function is the highest degree of the variable of the given function. Sometimes it can be 1, 0 also. For example, here the degree is 0 because the x is not there. If you write the x here, the power of the x is actually 0. That's why the degree is 0. X to the power 0 equal to 1, by the way. That's why you can just only write 3 here. So these are uh, many things can happen. That's not the problem. The point here is so that you can identify the degree of the polynomial. So degree is what? Degree is the highest power of the given polynomial function. All these things. These are like x to the power n minus 1, x to the power n minus 2. Basically, when it is written this way, sometimes it gets crazy to you people. Let me try to bring it a little up so that you all can see. I think let's make it 20. Okay, now you can see the whole part. So this n minus 1, basically it means the value is decreasing. If n is 10, 10 minus 1 means 9, and this way it is decreasing, okay? This is what it means. Now, important one, identifying polynomials. Suppose we said that we give you the definition of polynomial function. How can you identify it? So let's look at this a little bit. This a is the coefficient and n is the power, but this power you will notice in the next page, this power has some special property. This power cannot be negative. Okay, this power cannot be negative. This power cannot be root. Then it is not a polynomial. Uh, like 1 by 2, 2 by 3 fraction. It will not, the power of x cannot take the fraction. The power x cannot be negative number. Uh, or the variable itself is above the number, which is called exponent. These are not polynomial. Okay, these are not polynomial. And from the graph, if you see there is some hole, this is called hole. If in between the graph there is a circle, and circle is like this kind of empty, no black color there, that means it's a hole, then it is not a polynomial function. If the graph is not smooth, polynomial function is smooth and continuous. Okay, the graph has to be smooth and continuous. If there is corner or cusp or gap, hole, then it is not a polynomial function. Okay, if there is like two part, these are not polynomial function. Polynomial function has to be like smooth and continuous. It will go, if it start from somewhere, it will continuously, it will go this way or that way. Eh, then they will be the polynomial function. These are not the polynomial function. These are not the polynomial function. Now we'll try to identify which one is polynomial, which one is not from here during the class time, or you can even practice it now also, before the class also. What is happening? Okay. Now power function. Now um, there is two kind here. One is power function, and another one is exponential function. Let me give you the difference so that you can understand it clearly. So this is x squared. If x equals to x squared, see variable is down here, power is up. Now if I write 2 to the power x, then it is exponential function. Power is above the constant term. Suppose y equals to 2 to the power x. This is called exponential function. We will discuss exponential function in detail. We have full classes on this kind of function. So yeah, y equal to x squared. This is power function, and we have massive difference between them. We have massive difference between them. Like this kind of power, the rate of increase is too fast in the exponential function. And that's why sometimes in our daily life also we can say that the growth is exponential. If something's growth is too fast, this is called exponential growth. This and that. We will discuss them in separate class. So power function is what? X to the power x square, x cube, x to the power 4. These are called the power function. Now notice that this can be two types. This power can be even number, this power can be odd number. Okay, this power can be even number like 2, 4, 6, 8. If the even number, then their graph is like this. So if the power increases, what happens? The graph becomes narrow. Okay, you can see x square graph is red color, x4 graph is blue color. But this point, vertex point is same. Also, this point and this point is also same. Okay, graph becomes narrow here if the power is more. See, if the power is even more, the graph becomes narrower. But for the x cube, this is the x cube graph, and same thing will happen if the power increases. The graph becomes narrow about the y line. Or you can, in your mind, you can think graph will come closer to the y line. You can think if the power becomes bigger. See, And in your mind, actually, these are very important two graphs, very important types of two graphs that you should actually have it in your mind, like, because in our future conversation and discussion, we will refer to these two types very frequently. Okay, so x square graph is what? Like this parabola, open up. X cube graph is what? This is like this. This will go in the right direction, it will go up. In the left direction, it will go down that way, and it's a curve, of course. And what will happen if it is a negative? The graph will go, this graph will go down, and this side will go. This will have the flip about the x-axis. So if there is a negative here, negative here, then basically the graph will be something like this. If it is negative, if you give a negative here, and if you give a negative here, the graph will go down like that. Flip about the x-axis, it will happen. Okay, common points are these. Here is common point is this point 1 1 0 and minus 1 minus 1. These are the common points, and as you can see, when it is x squared, we have written it here. When it is x squared, then even if you put a negative number in the x, answer is positive, because the square 4 8 they makes it positive. But if it's cube, then for minus 1 it is still minus 1. Okay, and here is the transformation, another very important concept. So if it is x cube plus 2, what will happen? The x cube graph will go 2 unit up. Okay, if it is x plus 1 whole cube plus 2, so for this plus 1, graph will go left 1 unit, and for this plus 2, graph will go 2 unit up. See what happens this one. See what happens this one. So the graph is now here. Let me draw it so that you can understand. For this one, what happened here is the graph came here for this one, and for this plus 2, what happened here is the graph went 2 unit up here. This is for this plus 2. As I said, for the this is x to the power 4 graph, let's say so, and then minus x to the power 4 graph what will happen? The graph will have a reflection about the x-axis, flips the graph upside down. And what will happen about this? See, this is cube graph. So if it is a minus 2, the graph will go to the plus 2 along the x line. So that means the graph will go from here. Graph will go here. First of all, this is for this number, and for this number what will happen? This is minus 1, this is minus 1, so the graph will come 1 unit down for the minus 1 along the x line. And for this minus, what will happen is, as we said, the graph will have the reflection. The original graph will have the reflection about the x-axis for this minus. That's why the graph is, this side is going to the other side. So very important for graphs. X square, let me show you, write it here. X square, please practice this. X square, then minus x square, then x cube. Of course, fx equals to y equals to, write that. Very, very important. If you do not know what is the shape of this graph, please draw them couple of times so that it stays in your mind. Whenever we refer to this kind of thing, automatically it comes to your mind. These 4 graphs are very, very important. Like in this kind of discussion in the polynomial and in the subsequent discussion, we will refer to these 4 of them very, very frequently. So you should, like, without any calculation, you should know that, okay, x square graph, teacher is talking about, this is that graph. X minus x square, okay, down. X cube, okay, the graph will go this way, like this way, and then go up. Okay, this is minus x cube, now the graph will go the another side of the y line. So this way. we'll try to graph this kind of function in class practice. That's the hope. Now another thing, which is real zeros. Real zeros are basically x-intercepts. Okay, x-intercepts. And now, as you know, this is level 200, so somewhat advanced topic. Normally, you have seen the graph is like only one part. Let's say this, and then finished. Now you see the graph goes many. There is many folds here, etc., etc. So you can see that this graph at this point crosses the x-axis, at this point crosses the x-axis, at this point touches, at this point again crosses the x-axis. First of all these points, this one, this one, this one, and this one, all of them are x-intercept, or they are the real zero of the function. Okay, now it's written here. If it is real zero, then x minus r is a factor. These are the theory about this thing. Because if x minus r is a factor, then r is a real zero. That is the logic. And how do we identify the y-intercept? Suppose y-intercept is here in this graph. How can we identify y-intercept? We can identify y-intercept from the constant term. From the constant term. We can identify the y-intercept from the constant term. So this is what happens when sometimes we are in the class. Okay. But the good news is I'm actually recording it in my computer's built-in software. That's why even if Zoom kicks me out or anything happens in the world, it doesn't matter. Yeah. Okay. So this is like, I was thinking at this point, I was thinking about the other things. So quickly, let me tell you that a couple of months back, we visited a place, very narrow place in the hill tracts of Chittagong. So that day it was so rainy when we stayed in that tribal home, and we stayed the whole night there. In the morning, it started raining too heavily, and I was like, oh my god, how these people will survive here. And I saw, to my surprise, then they have all the preparation for that. And interestingly, we are the one who was scared during that event. They were chilling, kind of, they have the point is, they have the preparation just like us, because we know that this can come, this can happen, so we keep the preparation. Anyway, let's go to the next one. So real zero means what? Let's repeat. Real zero means the x-intercept. Okay, x-intercepts. This is the real zero. Okay, now notice one thing here. Here the graph crossed the x-axis, here also crossed, but here it is touch. What is it? Why is that happening? This is because of multiplicity. This is because of the multiplicity. Multiplicity means what? Multiplicity means the power of the real zero. Okay, power of the real zero. Let me explain it clearly. Power, see, one real zero will come from here, because see, this into this into this. From the zero product rule, we can say that, okay, if x minus if x minus 3 equal to 0, then x equal to 3. So x equal to 3 is one answer. Okay, x equal to 3 is one answer. Then x equal to minus 2 will be one answer. If you see plus 2, answer is actually minus 2. If you see there is nothing here, that means one answer is 0, because we have x to the power, x power is 0. So x power is 0. Also we have real zero also 0, because x equals to 0. This is x equals to 0. When there is nothing, that means x equals to 0. Another way to explain it is when there is something into something into something equal to 0, we are trying to find out x-intercept, that means y equal to 0. That's why you can write equal to 0. So x equals to 0, this equals to 0, and this equals to 0, we can write. Okay, and from there we can get this 0, minus 2, and 3. All right. So multiplicity. What is the power of x? Power of x is 0. What is the power of this x plus 2? It is 3. So we will say multiplicity is 3. Okay. Oh, this power of x is actually 1. If it is 0, then it becomes if it is 0, then it becomes 1. So x term vanishes. That's why it has to be 1. It has real 0 is 0, but power is 1. Yeah, that's correct, because if it is 0, then it becomes 1. Then we will not have to write that x. Okay. So multiplicity, x to x multiplicity is 1. This minus 2 multiplicity is 3, and this one multiplicity is 4. It means that this is x minus 3. So you know real 0 is plus 3. So at plus 3, since the power is even number, the graph will only touch. So if the multiplicity is even, then the graph at that point will only touch. Like it will go there and touch it and then come back. Like you go there and just touch it and then go back. You just go there and touch it and then go back. You know. Then if it is multiplicity is odd number, 1, 3, 5, this kind of, in all those cases the graph will cross. Okay, the graph will cross at that point. So it is written here, touch, cross. If it is even, touch, odd, cross. This is another theory. A polynomial cannot have more zeros, including repeated zeros, than its degree. So total degree, more than that, it cannot have the more than that. Suppose we have, let's say if there is x square, let's say x square minus x, then plus x square minus x minus 6. This is a quadratic function, fx equals x square minus x minus 6, and since the maximum power is 2, so maximum it can have 2 real 0. Okay, this is what it is saying. The maximum power, but it cannot have 3 real 0 because the maximum power is 2, so maximum it can have 2 real zeros. This is what it's saying. Turning point. And now another thing. Then we have turning point means here. See, the graph was going down, down from the always. For your understanding, better understanding, always start from left side of the graph. Then everything will start making sense clearly. So graph was going down, 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 down. Then at this point, the graph has started going up. That means this is the turning point. Then goes up, 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 up. Then this is another turning point. Okay. And if a polynomial function has degree n, there it can have more, at most, n minus 1 turning points. What does it mean? It means that, see how many turning points this graph has. 1, 2, 3, 4, 5. That means the degree of this polynomial function was 1, 2, 3, 4, 5. Degree of this polynomial function was maybe 6 because it has 5 turnings. Okay, because if the power is 6, then it can have maximum 5 turning. Always 1 less. But it can have sometimes 4 turning also in some crazy situation. 3 also. It can have 3 turning also. But maximum it can have 5 turning if the power is 6. That is what this theory is meaning. This is directly taken from the book. Oh, we already said about that. And this is the counter logic of this logic. Now the end behavior, this is relatively just a minute, give me a second. So about the end behavior, if you look at the degree of this function, as you can see, this is the degree is minus 4 x to the power 5. So what is the degree of this polynomial function? Degree is 5, right? Maximum power. And actually the this graph, if you look at this graph, then the end part of the graph will depend on this maximum power. The reason is this, because when the values are large enough, then actually the graph heavily depends on this maximum power of the degree. That is the reason. In the next page, we will show you the with detailed explanation. But this is the reason why it happens, because when you take this term commons, you can see other terms are actually below the denominator. That's why if x increases, this part actually do not increases much. This actually increases way more faster. Let's look how it happens. This is the leading term, and this is actually the end behavior will depend on the leading term. This is x to the power 5, then the end part of the graph will look like x to the power 5 graph. That means odd powered graph. These things is written here. Now let's look. Suppose x to the power 4. So x to the power 4 graph is what? Normally x to the power 4 graph is like this, right? That means the end part of the graph will look like this. See the example. This is the, see, this in the left side it was going up, in the right side it was going up. So in the both side we have this and this. So that is the thing what we mean. But in the middle, in between, they can have a lot of things. Okay, but in the left and in the right, they will act like it is x to the power 4 graph. This is what is called end behavior. End behavior means the end part, the final part, will act like this function. But in the middle, there can be a lot of other things, because as you have seen, let me go back, because as you have seen, there are many other terms. So in the middle, there can be crazy things. But at the end, it will happen like that. So from the end behavior, what we understand? We understand that what will happen at the end part of the graph. And why we are learning this, the reason is actually when we will start drawing them, this will help us. These concepts will help us. We will try to draw later in the coming class. We will try to draw that complex type of graph. So this is x cube. So see, end part will look like x cube graph. This is minus x cube. That's why end part will look like that. This is minus x to the power 4. So end part is just a reflection. And this one is also just a reflection of the odd power. In class practice, we can practice this kind of thing. This is the power. It will depend on the power, of course. From the first one, as you can see, this is x to the power 7 and negative. So basically, it is a negative odd power function. So that way it will act. Yeah, and that's all for. You will try to identify which graph this one is, and this will go as a participation quiz. That's all for today. Thank you all. Thank you very much, and have a good day, everyone. See you all in the class. Bye bye.